Hi, in this lecture we are going to talk about the concrete implementation of the ternary search tree. So let's get started. We are going to have two classes. First of all, one for the node. So node with the object. It's going to have the constructor, so we will have the init with the self. And it's going to get a character because we are going to assign a character to every single node. This is what we have been discussing in a theoretical section. As you can see, that every node or vertex in that given tree-like structure is associated with a given character, C, A, T, R, and so on. Okay, so we will have the self.character is equals to the character. Okay, let's make some indentation. We will have a left node. It is equal to none at the beginning. Okay, we will have a middle node is equal to a none, and we will have a right node is equal to none at the beginning. And of course, every single node is associated with a value. It is equal to 0 at the beginning, for example. So as you can see, we have the nodes. Every single node has a character, and we are able to associate a given value to a given node. 23, 6, 46, and so on. Okay, then we will have the class ternary search tree with the object. Okay, and of course we will have first of all the init method with the self. We are just going to initialize the root node. So we will have a root node is equal to a none at the beginning. Then we will have the put method. The put method is going to have a key and a value, of course. We would like to use ternary search trees as a dictionary basically. And we are just going to set the root node to be equal to the self.putItem with the root node, the key, the value, and the index. We would like to start with the 0 index of that given string key. Okay, so we will have the def putItem with a given node, with a given key, with a given value, and the index of the key. This index is going to track that what character we are considering as far as the key is concerned. So we have been talking about that if we would like to insert the caret as the key with the value 68, we have to consider the first character of the key with 0 index because indices starts with 0. Then the second character, third character. So this index is going to track that what character we are considering at the moment. In this case, it is the index 0, then index 1, then index 2, and so on. Okay, so we would like to get the given character as the key with the given index. Okay, if the node is equals to a none, we know that we have to instantiate that given node. So the node is equal to a node with the given character. What is this case? As you can see that here, for example, we don't have to create a distinct node for that given character because there is already a node in the tree-like structure. We don't have to create a node for A as well, for T and R, but we have to create a node for the second R, then for the O, then for the T. Okay, so that's why we bump into a situation that the node is a none. We are going to instantiate it. And anyways, we just have to check that if the character is smaller than the node character, it means that we have to go to the left. So the node, left node is equals to the, and we call this method recursively. We put the item with the node, left node, because we are going to go to the left, with the key, with the value we would like to insert, and of course we do not increment the index because it means that we keep considering the same character of the key. Of course, we are going to increment the index and going to consider the next character in the key if we are able to insert that given value, but here we keep traversing the tree-like structure. So if the C is greater than the node character, We do approximately the same, but for the right node, we call this method recursively put item with the node right child or right node, with the key, with the value, and with the index without incrementing the index value. Elif, we check that if the index is smaller than the length of the key -1, because indices starts from 0, okay, we know that the given character is equals to the node character because it's not smaller and not greater in the alphabetical order, and we are not at the end of our key. The index is smaller than the length key -1. The length key -1 represents the index of the last character as far as the key is concerned. In this case, we have to go to the middle child. So node, middle node is equal to the self. Put item with the node, middle node key, value, and what's very important that we have to increment the index value. This is what we have been discussing, that basically we keep incrementing the index and keep considering the next character in the key if we keep going to the middle node. In this case, as you can see, C is present in the tree, so we keep going to the middle child. Then we keep going to the middle child and keep incrementing the index in order to be able to consider the next character of the key. But let's take a look at the next example. For example, for the carrot, okay, we increment the index if we go along to the middle child, but we do not increment the index if we go to the left. As you can see, we go to the left, but we haven't incremented the index, so we keep considering the same character as we did on the previous iteration. Okay, so if we go to the left or go to the right, we do not increment the index. If we go to the middle child or the middle node, we keep incrementing the index, which means that we keep considering the next character of the key. Okay, and else we know, what do we know? It's not smaller, it's not greater, so the given character is equal to the node that character, and the index is not smaller, so basically we are considering the last character of the given key, which means that we have to insert the value here. So node.value is equal to the value. So for example, let's take this example, the C, we go to the left and we keep inserting A there, then P, then L and E, and if we are at the end of the key, so basically the index is equals to the length of the key, we keep inserting the value. This is what's happening here. Okay. And anyways, we just have to return that given node. So that's all about the put item method. Okay, in the next lecture, we are going to talk about the get item method. Thanks for watching.